Good morning. All right. So welcome to this talk, which is titled, I think it's the longest title of the entire conference. So the title is Building a Mobile Enterprise Application with Xamarin.Forms, Docker, MVVM, and .NET Core. So a lot of topics to cover. The goal is basically of the next 45 minutes to give you an overview of how a real-life application can be built in Xamarin.Forms using MVVM, so a very good architecture based on the MVVM pattern. And then we're also going to see how the backend can be created in combination with microservices built with .NET Core and then hosted inside of Docker. My name is Gill Cleeren. I'm coming from Belgium. I work as an architect at Ordina. I'm doing a lot of mobile stuff there. I've been doing Xamarin for quite a few years already. The blogs, on my blog, you can find the slides. The demo I will show you in just a second where you can get that. So go to my blog if you want to download the slides afterwards. I'm also proud to say that I'm doing a lot of Pluralsight stuff, including quite a few courses on Xamarin. So if you're interested in learning more about Xamarin, take a look here so that on this page you can find all my courses. All right. So what are we going to be doing today? So I'm going to start by showing you the overall application structure and architecture. Then we're going to dive in the first big block of the presentation, which is going to be about the Xamarin application architecture. We're going to discuss MVVM. We're going to discuss dependency injection. We're going to talk about loosely coupled messaging. We're going to see how we can do navigation. We're going to see how we can communicate with that backend, which is then created using microservices in .NET Core and hosted inside of Docker. So as you can see, it's quite a lot of content to actually explain to you in 45 minutes. So let's get started right away. So we'll get started by taking a look. By the way, there's still seats here in the front, people. There's still a lot of seats here in the front. So if you want to take a seat, you can join here in the front. I don't bite. We're going to start by taking a look at the solution structure. First, a little disclaimer, the demo I have not built myself. The demo is built by Microsoft. You can actually get the demo from microsoft.com/net/architecture, where Microsoft explains their approach and their vision on building enterprise applications. And the application that I'm going to show you in just a second is basically how I also build my applications. And the application is called is basically a store where you can actually purchase stuff. And we're going to dive into that architecture to explore how a real-life application can be built. Well, this is a bit of a schema that gives us an overview of the application. So on the front end, the application, because the application that we're going to be looking at is basically part of a much bigger setup, and we are going to focus, of course, on the Xamarin part. So there is actually a front end built with Xamarin.Forms that we're going to start by taking a look at in this presentation. The application next to a Xamarin front end also has on that same backend basically an HTML front end, purely an MVC application in the backend, and there's also a single page application variant, which is then basically talking with a backend, so the backend for the front end. So we're going to focus, of course, on that part first. Then we're going to see the backend, and the backend is basically built in a microservice way. There is an MVC application which is also hosted in Docker. We probably won't have time to take a look at that. But then you see different microservices on the right there. One for the identity, one for the product catalog, one for the ordering. And we'll take a look at that near the end of the presentation. So this is basically the global overview of the architecture, how it is actually set up. So let's first take a look at the finished application. I did stop it, I think. So the finished application is... let's dive in the running application first. So I did already boot it up, but it seems to have shut down. All right. So it's going to start. All right. So let me first show you the scenario. So it is keyboard go away. So it's like I said, it's a store front end, whatever the architecture is, whatever the application is, doesn't really matter. You can actually browse for shirts and sweaters and I don't know what. So the application is like I said, it's called eShop on containers. So you can download it from microsoft.com/net/architecture. You can look at your orders. You can look at your basket. You can also from here filter down on the type of clothing part that you want. There's a couple of settings. Really, let's not dive and lose too much time into looking at the finished application. I think it's much more useful to see how it's actually built up. Now, before we actually start looking at the code, we'll start by taking a look at the solution structure, because that is, of course, also interesting to start with. Did it actually stop it? Yeah, all right. So if we look at the solution structure here, we can see that there's actually a couple of big blocks, and we're going to start looking at the mobile application block. So the mobile application block basically contains a Xamarin.Forms application, because this is, in my opinion, definitely an application that really shines with Xamarin.Forms. The front end is really not that complicated, and we can already build complicated front ends with Xamarin.Forms. This type of application is really where Xamarin.Forms shines. And we're going to take a look at the setup for this in just a second. So there's a core that is basically your shared code that you can see right over here. And then there's different application heads, so the target applications. There's an Android app, there's an iOS app, and there's a Windows application on top of that. We'll dive in that in just a second. Then, like I said, there's a couple of web applications. There's actually an MVC application, a plain old MVC application built with ASP.NET Core. Then there's the Web SPA, so the Web SPA project. That's actually the backend for the front end. So that's basically where the front end will actually, the SPA front end will actually communicate with. And then there's also a status head. We're not going to look at that one. And then we're going to, near the end of the presentation, we're going to explore basically this part, which is actually the services that actually make everything run. There's a service that talks, that manages the catalog. There's one that manages the basket. There's also a service which is a bit more complicated, which handles all the ordering. So that's basically the whole setup of the solution structure and the solution architecture. Well, for the rest of the talk, we are going to explore different parts where I think you have to really investigate in how it's actually done. All right. So let's go back to the slides for a minute. And as mentioned, we are going to start by exploring the Xamarin part. Like I said, the application is built with Xamarin.Forms. And Xamarin.Forms, I hope everyone knows, is basically a really good application, a development platform that can allow us to build shared applications that run on iOS, on Android, and on Windows. Now, building reusable code in Xamarin is all about using the MVVM design pattern. You probably already heard a lot of talks about Xamarin, about MVVM, and I'm going to make sure that you understand the most interesting building blocks of the pattern. Now, the pattern, the model view ViewModel pattern, is a pattern that, well, in my opinion, really shines with the use of XAML-based platforms. And Xamarin.Forms is, of course, a XAML-built or XAML-based platform. It's an architectural pattern which in itself really doesn't differ that much from MVC, from the model view controller. It's based on the same principles. It's already invented, so it's based on the MVC pattern, which was based on presentation model by Fowler, which was invented many, many years ago. So really not that different from what we've been doing already for quite some years. Now, MVVM in itself became popular with Silverlight, a Windows Phone, and because of the fact that Xamarin.Forms is also using XAML, data binding, commanding, we can really apply it here in a real-life application as well. Now, what is MVVM all about? If you've never heard of MVVM, let me give you a very brief overview of what the pattern will be allowing us to do. Well, this is what we've been doing for many, many years. We build an application front end, we build a view, we build XAML code, and we build code behind. Nah, not very good. We don't like code behind anymore, because the problem with code behind is that all your code basically goes in one class. On one line, you go to the model. On the second line, you update the UI. Try testing that, I dare you. It's going to be really hard, because you have a monolithic block of code that is really hard to separate and test things in isolation. So the code behind approach was nice when we were all young. That time is gone, and we're now basically moving on into into better architecture for this type of application. So what we're going to use is MVVM. Now, in MVVM, we still have a view. The view is still XAML, but there's only a tiny bit of code behind anymore. There's still going to be a bit of code behind, so things that really have to do with the view, but for the rest, we'll be focusing on this extra abstraction that we are going to include here, which is the ViewModel. And the ViewModel is nothing more than a simple class that does 2 or 3 things. It exposes state, well, that's data, and operations, and that will be commands, and I'll show you that in just a second. Now, the view and the ViewModel actually need to know each other, and they're going to do that because of data Still nothing? Yeah, all right, I think it's working. Thank you. All right. So this is the ViewModel pattern in a nutshell. It is really a pattern that you have to learn and to have to follow to build maintainable and testable applications, because that is one of the biggest benefits of MVVM. You actually have a nice abstraction of your different building blocks, your different layers in your application, and it's easy, much easier to test your code in a unit test because you have your code in isolation. It also allows you to change the view without updating the view model. Basically, you can have your designer do whatever you want him to do, and you can still continue working with your view model. And also the same goes for your view model. When the view model changes, well, your model doesn't really have to change. Now, if you look at the code, what you will simply see is that the view code, the XAML code, is going to contain some data binding. And this is a couple of pieces of code that I've taken from the finished application. And as you can see in the first line, well, it does some data binding. There's an entry which is linked to, I think, the username. And then the second one is a label which is going to be bound to a list of errors. That's going to be used for validation purposes. And then we have a list view, which is going to contain a couple of, I think it's campaigns. And there's also converters. So if you know a bit of XAML, you already know that that converter is probably going to hide this thing when there's no items in the view, and it's simply going to go to data bind to an observable collection of campaigns in this case. Now the view model code, like I said, is really nothing to be scared about. It's simply a class which in the end needs to implement the iNotify-property changed interface. In the code that we'll take a look at in just a second, it's done in a different way, but in the end, it still implements that interface, the iNotify-property changed interface. And that's a really important interface because data binding in the UI will be listening for this event, so the property changed event being raised by the view model, and it will automatically update the view code, or the view, what you see in the view. And as you can see, what it is exposing is two things: state, data, properties, username, password, and the second thing is commands, so that I don't have to write event handlers in my UI code anymore. You should never have any real event handlers if they do anything with the model. That is, if they simply do something with the view, that is still okay. So let's dive into the sample application. All right. So when we take a look here in the solution structure, we are going to, all the code that I'm going to be showing you is shared code. So with Xamarin.Forms, we can reach 90% of code sharing, and this application really shines in that because most of the code is actually shared. So we start here with models, my domain model basically. There's a basket class which contains a basket item, which, as you can see, is a very simple class that simply has some properties, ID, product name, and so on. They are used in several ways. They are basically used throughout the entire architecture, but they are going to be used in any case by the services. So there's a services folder here, for example, which talks with, there's a catalog service. We'll dive into that one in just a second. But as you can see, what this one is going to do, it's going to be your layer which will retrieve a list of catalog items. And that's going to be used then by the view model. Because we really only have a connection between our data layer, our services layer in this case, and the view model classes. So the next block, and don't worry if this is going a bit faster, we'll dive into different blocks in a bit more detail in just a second. So then the services are actually used from the view model. So let's take a look at the login view model. I didn't really show you the login page because I already was logged into the application. So the login view model is basically a class that does, like I said, two things. It exposes state and operations. State is data. My UI needs to bind on state, on data. So this is a login view model. What it will typically expose is a username and a password. This is not simply a string, it's a validatable object. I won't be able to show you validation, but this is the way that validation is done. It's actually binding to objects that can validate themselves. But in the end, it's just a string on which you're going to be binding from the UI. The next thing that the view model also does, it's actually exposing commands. As you can see here, we have a signing command, we have a register command, things which will also be triggered when we do something in the UI. We'll take a look at commanding in just a second. And then my views, well, my views will be binding somehow. We'll still have to look at that. They will be XAML pages, because it's Xamarin.Forms. The entire UI, almost the entire UI, is going to be shared. So also the view pages are going to be written once and used across iOS, Android, and Windows Phone, or Windows UWP. And if we look here, and scroll down a little bit because there's some styling code here, we will find somewhere a login entry, a lot of code here. For example, here we have an entry which is going to accept the password, so it's binding to the password in a two-way mode. Two-way is important because then the view will actually be able to update the view model and vice versa. It's a two-way binding between these two. So that should already give you a bit of an overview of how the different layers are connected. All right. Now, let's dive in a couple of extra pieces because a lot of things might still be unclear. Well, now what is that view model really all about? Well, like I said, it does two things. It exposes state and operations, and very importantly, it also needs to update, it needs to notify, let's say, the view about changes. Because if the view model changes, if the list of products, for example, has changed or the price has changed, we need to update the view somehow. And we're going to do that using an event-based system. The view models are classes that in the end, like I said, need to implement the iNotifyPropertyChanged interface, which is a very simple interface. It's called, it has just one event called the PropertyChanged event, and you need to raise that whenever a value changes on your view model. For example, when the user is entering the username and the password, we need to update the view model that value has changed. But when the view model has validated that username and password, we need to update the UI maybe of login error. So there's a two-way communication happening between these two. Now in the application, we are not going to directly implement the iNotifyPropertyChanged on the view models. We are actually using a class called the extended bindable object. And the extended bindable object in the end inherits from bindable object, which is a built-in Xamarin.Forms thing, which then implements the iNotifyPropertyChanged interface. Let me show you that. So let's go back to a view model. Just any view model will do. So let's go to the login view model, for example. And as you can see, the login view model does inherit from ViewModel base. This is readable for everyone in the back, right? I tested it, but I have good eyesight, so still need a bit bigger. Okay, no worries. It's all for the same price. You don't have to pay extra. So let's put it on 24. Is better? All right. So as you can see here, we have the ViewModel base as the base class. We do an F12. We go to the extent. So the ViewModel base is a class which does a couple of things. I want you to remember one thing. It's called the initializeAsync method. I'm going to talk about initialization of the view models. This method will then come into view. Keep that in mind that actually is here on the ViewModel base. Then we have the base class for this is the extended bindable object. Like I said, that's the class that we are going to inherit from, and that's the class that in turn inherits from the bindable object. But this one does something special here. It has a method called rasePropertyChanged, which will call onPropertyChanged. And onPropertyChanged is implemented on the bindable object. And the bindable object, like I said, is a built-in Xamarin.Forms class. And down here at the bottom, it has the onPropertyChanged implementation. So what we need to do is when we change something in the view model, we need to basically call this onPropertyChanged. So what are we going to do in the view model? So in the login view model, when a value changes for one of the properties, we are going to call that rasePropertyChanged, which is then implemented on the extended bindable object, which then in turn calls the onPropertyChanged and then notifies the view, the data-bound view, of this change in the data. And so that is how my view and my view model can communicate in terms of data. Now what we haven't covered yet is how we can, when we click on a button, how can we do something? Yeah, typically you would write an event handler. And I see a lot of people doing stuff in the code behind and then invoking a command. And I'm really not a fan of that. Because if you're doing MVVM right, you want to also implement commands correctly. And let me show you how we can do that. Now what is a command really? Well, a command, if you look at the command pattern, it's basically going to say, well, we wrap everything that we need to work with to invoke something at a later point. We wrap that inside of a type, into an object. And that's what your command is going to be. Now commanding is implemented as a class that implements the iCommand interface. And again, Xamarin.Forms is built with MVVM in mind, so they also implemented the iCommand interface. And the iCommand interface is really simple. It has a couple of things in there. Namely, the most important one is the bottom one, the execute method. That's the one that you want to invoke when something happens in the UI, when the user clicks on a button or when the user wants to navigate, that sort of thing. That will contain the actual code that we want to invoke. There's also a can execute, for example, that is used to bind whether or not the command is available. So you could bind your enabled property of a button to the can execute. And the can execute changed is an event handler that needs to be fired when the can execute is changing. Now the problem with with commanding is that commanding in Xamarin.Forms is only available on a couple of built-in classes and built-in controls, such as the button. In fact, I should say the button base allows commanding, but that really will limit you, because then you cannot, for example, say that when I have a list view and I hit an item in that list view, I want to invoke a command. It's out of the box, not available. Now to fix that, we are going to use something called a behavior. Now what is a behavior really all about? When you think about a real-life behavior, it's something that defines you. It's a functionality of yourself. Well, in Xamarin.Forms, we also have the ability to work with behaviors. They are basically extra functionalities we are going to add. And the good news is that Xamarin has implemented something called the event-to-command behavior, which is a behavior we can add on just any view, such as the list view, which does not know about commands, but we simply inject that extra functionality of allowing us to link a view event with a command on the ViewModel. And that's what you see here. I'm going to show it in the demo in just a second. This is an event-to-command behavior. You can go to the Xamarin website and you will find this class. It's on there. You can just copy-paste it into your own code, like we all do. And then, how are we going to use this then? Well, we go to our view, and as you can see here, I have a list view, and that list view has a behaviors property. And we can actually say, well, I'm going to use my event-to-command behavior, which then allows me to link, in this case, the item tapped event, and I'm going to link that with an event on my ViewModel, which is the order detail command. And once again, they know about each other. Now, in the application, you will also find a lot of these guys, the tap gesture recognizers. They are also a Xamarin.Forms thing, and what they will do, they will allow you to link, for example, a stack layout with a command. Therefore, those guys, you don't really need the event-to-command behavior. Let me show you that in the next demo. So, where are my commands? Like I said, my commands are implemented on my ViewModel. So down here, I have a couple of commands. For example, on the login screen, I will have a sign-in command that needs to be invoked when I click on the whatever sign-in button I have in my view. So what I'm going to do there is I'm going to create a new command, and I will asynchronously, my mouse is acting a bit weird here, all right. So I'm going to invoke asynchronously the sign-in action. That's this method that I want to invoke in this particular case. Now, how am I going to do that? Well, don't write anything in the code behind. If we take a look at the code behind for the login view, over here, you will see a little bit of code. I'm going to come to that in just a second, but there's no event handlers. Right? We don't do event handlers. A lot of people doing MVVM still use event handlers. Like I said, I'm not really a fan of doing that. So what I'm going to do, I'm going to link my UI with behaviors or with those tap gesture recognizers. So for example, if we go down a little bit, here we have the login button. As you can see here, the login button is implemented as a cell within a grid that contains a label. And because it's actually using a UI layout manager, a grid, we can use the tap gesture recognizer. And like I said, the tap gesture recognizer knows about commanding. So I can invoke a command here, the mock sign-in command, on my ViewModel. That works out of the box. Now, if we take a look at the list view, for example, that's in this one, the list view does not know about commands. I can start typing the command property here, and it will not know about it. It will not know about commanding in this particular case. It doesn't know about it. So we need to use that behavior thing. The behaviors are implemented. If we go to the solution again, so there is a behavior over here, and there is the event-to-command behavior. This is written by smart people, so I didn't write it myself. I just copy-pasted it. This is available on the Xamarin website. You can simply put it in your code, and it uses attached properties to allow you to specify what needs to be your UI event and what needs to be your command that needs to be linked. And I'm going to simply use that here to specify that in my list view, I need to use a behavior, the event to command behavior, that will be invoked when the item tapped event is going to be invoked in the UI. And that will then trigger the execution of this particular command in my ViewModel, right? Now, if you think about it, there's an important piece of the puzzle missing. How do my view and my ViewModel know about each other? There's always where people struggle with MVVM. How do I actually create a link between my view and my ViewModel? Well, MVVM is all about loose coupling. Not creating tight links between views and ViewModels because then you end up with a tightly coupled mess again. That's not what we want. We want to have loose coupling. And how can we create loose coupling? Well, by creating unidirectional bindings. So what I'm going to do is I'm going to have my view know about my ViewModel. And my ViewModel will know about my model. But you have the errors in that direction, but in fact, you should not have the errors in the opposite direction, because then you will create another direct or tight connection between the different layers. So this way it's going to use an event-based system, right? So my view needs to know about my ViewModel because it needs to data bind on it. My event model needs to know about my data model because it needs to ask for the data. So that's why I have those links created. Now, how do we do that? Well, from a practical point of view, you can do that in two options. There's two options to build this type of setup. You can do a view first, or you can do a ViewModel first approach. In this application, we use view first. I typically also use view first. ViewModel first works nicely with WPF, but doesn't really lend itself to Xamarin.Forms that much because, yeah, there's a couple of things which are not in Xamarin.Forms' XAML implementation. So we've typically used the view first approach. Now, what does a view first approach do then? Well, we have XAML, which needs to know about the ViewModel. So we can do it very simply, like here. We can simply, in the code, in the XAML code, specify or invoke, let's say, the ViewModel. In this case, I'm simply saying that the view, the page, will actually use as its binding context the login ViewModel. That's a very simple, but still maybe a bit too directly tight connection between my view and my ViewModel. We can also do it from code behind. When you may be saying, whoops, code behind, we weren't going to do anything in the code behind. Like I said, you can do stuff in the code behind as long as it doesn't do anything with the model. And this is not doing anything with the model. It is just specifying what is the view model for the view. So it's not really anything that has to do with the model. So that's okay. Now, what I typically tend to do is I use an intermediate class. There's something called the ViewModel Locator, which is a class that knows about the view models on one end, and it also is known by the views. So somehow, the views will ask the ViewModel Locator, hey, dear ViewModel Locator, I need this particular view model, and it will retrieve it for it. Let's take a look at that ViewModel Locator implementation. So the ViewModel Locator is going to be inside of the base ViewModels class here, folder here. It is a class that is implemented in this case using an attached property called the AutoWire ViewModel attached property. Now what this thing will do, it's of type Boolean. Actually the type is not really important here, but it's implemented by the ViewModel Locator class, that is this class. And as you can see, when the value is set, it is going to call the onAutoWire ViewModel changed method, which is a method which is implemented down here at the bottom, and I'll come back to this code in just a second. So the onAutoWire ViewModel changed method does a couple of things. In this architecture, we base ourselves on a convention that we have a view and a corresponding view model. So we take the name of the view and we search for the corresponding view model, and then we simply use dependency injection. I'll come to dependency injection in just a second. But in the end, what you see here is that the view and its binding context are then pointing to the view model. So that is then used by the view. If you look at the view here, so the login view, and you scroll all the way to the top, what you will see is that we are in fact using that ViewModel Locator.AutoWire ViewModel, and I set that to true. So what that will do is it will bind, so it will trigger this this attached property that has changed. So that will automatically invoke this method, which then searches for the corresponding view model and sets it as the binding context for the view. So there is an intermediate between my view and my view model, and that is the ViewModel Locator. Now what you've seen here is already using dependency injection. Now dependency injection is used all across this entire architecture. So I need to spend some minutes talking about how it's implemented. So what is dependency injection really? A dependency injection is a type of inversion of control. It is asking someone else to do what you need, to give you what you need. I'm not going to create my dependencies myself. I'm going to ask someone else to give them to me. That's what we're going to do. We're going to use the dependency injection container in the application. This application uses AutoFac. I also tend to default to AutoFac. It works nicely in combination with Xamarin.Forms. So what are we going to do? So we have that container, that IOC container, sitting there in the middle. And you have an interface, for example, the iOrder service. Doesn't matter what it is. So you create an interface, and you create, of course, your concrete implementation. Now, your consumer, which is your ViewModel, needs to have an order service. So it's going to go to the dependency injection container, and it's going to ask, I need an iOrder service, please. And that that IOC container will then return to you, in this case, a real order service. So you paste all the dependencies inside of that container, and it's going to retrieve the concrete implementation for you. Why is this useful? Think of unit testing. If you want to unit test the view models in this architecture, you simply inject mock versions of your services so that you can isolate your view models for testing. It allows you to simply create unit tests that are not depending on the external dependencies, in this case, the order service. Now, let me show you how it's done. In this application, it's also done in the same class as the ViewModel Locator. Might not be a good place for this, but the thing is, as you can see, it's a static class, that ViewModel Locator. So this code, the registered dependencies, is called at the application startup. That's what we need. And what are we going to be using? Like I said, we are going to use the iContainer. This is probably not readable for anyone in the room, but it says autofac.iContainer. This is using autofac as the container to register all the dependencies with. So what are we going to do? In this method, which is called @application_startup, we are going to register everything that I need in my application. I'm going to register my view models. As you can see, I'm also registering services, and we'll take a look at the navigation service in just a second. And then I'm also registering, for example, the catalog service as an iCatalog service. So what I'm doing is I'm saying, hey, dear container, whenever someone asks for an iCatalog service, return him a catalog service. And I'm also using single instance, which is saying I'm going to use a singleton-based approach here. AutoFac lends itself to transient and singleton approaches as much as you want. So we are registering a lot here. How are we going to then use that? Well, let's go to the view models. For example, the catalog view model, for example. So the catalog view model probably needs a catalog service. And we'll take a look at the service in just a second. That's the thing that will retrieve the data. That's going to retrieve the data from a web service or whatever. So this one needs an iCatalog service, as you can see here. Now, AutoFac is smart enough that when someone asks for an iCatalog service, it will inject the concrete implementation, the actual catalog service. If we're running this in a unit test on our view model, we can inject a mock catalog service this way. So we haven't created a tight link between my view and my view model and my data service. And we'll take a look at the data service in just a second. Right? Okay. Now that is basically how we create loose coupling between a lot of components within my application. But there's one thing that is not covered by this. The problem is that your view models also need to talk with each other to pass data, for example. One view model needs to say to the second view model, the user has clicked on item 1, show the details of item 1. The problem is that if you start instantiating view model A inside of view model B and B in C, you end up with a spaghetti of tightly linked view models again. That is not what you want. You need to have another intermediate that allows your different view models to communicate, also in a loosely coupled way. How are we going to do that? Well, I'm going to use, again, a Xamarin.Forms specific implementation of something that Xamarin.Forms comes with by default, and that's the messaging center. The messaging center is nothing more than a simple implementation of a pub/sub model. View model A needs to send, or view model on the left here, needs to say something to the view models on the right here. How are we going to do that? Well, you would typically say, I create in view model A, view model B, and C. But that's not going to be how it works, because then you end up with a tightly linked spaghetti of view models. What you're going to do is this one is going to say to the messaging center, hey, I need to publish a message, right? And the other view models are going to say, well, whenever someone publishes this or that message, let me know. Right? So they will actually be notified by the messaging center that that particular message has been published. And so they can communicate with each other without creating a direct link between the different view models. Now, let me show it in the implementation. In the implementation, you will find the problem. One thing that I want to mention, I'm not really 100% a fan of the messaging center, because the messaging center doesn't allow you to specify types. It only allows you to communicate using string-based messages. So I tend to use a different custom-made messenger between my view models, but it boils down to the same way of working. So what you see here is that I have a class called message keys, which contains a number of messages that will be sent. For example, we have the implementation called add product. Now, if you take a look at where add product is used, let me do a go to find our references here. So we will find that this message is sent by the catalog view model. So catalog view model is the one on the left, and it will say, I need to let other view models know that something has happened. So what they will do is they will say messaging center.send this particular message. And they also can pass, in this case, a catalog item along. So they can pass an object along. On the other end, on the receiving end, let's say, we have a subscribe here. And that is, in fact, this is using lazy loading of Visual Studio 2017. So on the receiving end, so the view models on the right, they will register, they will subscribe for the add product message. So when that add product message is sent, this one will be notified. And it can execute code in that particular case. So when the add product has been raised in one view model, another view model will get notified about it. And that allows my view models to, again, communicate in a loosely coupled way. Now, the last thing I need to show you here, and then we'll go to the backend because I'm running quite behind actually, is the service layer. Something that is very often forgotten in an MVVM scenario is navigation. If you go to Stack Overflow and you search MVVM navigation, a lot of people get confused with navigation in this type of application architecture. That is because MVVM doesn't really cover navigation. So it's something you have to do yourself, and that's where people get confused. What I have here is a class called the navigation service. Now, Xamarin.Forms comes with navigation built in using the iNavigation interface, but it also doesn't, what you need to think about is when I want to do navigation, I shouldn't be doing that directly from my view model, because in that case, I will again create dependencies within my view model or my view code. iNavigation has something to do with Xamarin.Forms, so it's UI code. You shouldn't be doing that. So what I'm going to do is I'm going to put another intermediate in between, which is called the iNavigation service. Now, instead of talking about it, to save us some time, let me show you the navigation service. So the navigation service is probably in the services folder somewhere over here. There we go. So the navigation service, my mouse is a bit annoying here. So the navigation service, what it will do the actual navigation for us. It uses for that this thing here. That is the built-in Xamarin.Forms navigation. That's the iNavigation interface. That's the one I don't want to have inside of my view models, because that creates a direct link between view models and Xamarin.Forms, and I don't want that. So I'm abstracting that away in this class. It's basically separation of concerns that we're doing. So all the dependencies on iNavigation end up in this class. And there's a couple of methods. Basically, it's pretty simple class. It does a couple of navigation things. And what that will do, view first. So we basically say we want to go to that particular view. So that's what we're doing here. We are asking to create a particular view. And we're then linking that view model again with it, and we're using for that the iNavigation interface. Very importantly, remember that I said, don't forget that there's an initialize async method. That initialize async method, that is the one that lives on the base view model class. Why is that? Because if you think about it, in the view model locator, this one, in the view model locator, we register all the view models. So they are, in fact, going to be instantiated. You do not want to run a lot of code at the startup of your application. The only thing that you want is to create your view models so that they can receive messages, but you don't want to run code that already fetches data. You might want to do that, but not for all view models. That is why your view models have this initialize async method that will be invoked when we get that view model into the view. We only invoke that at when we actually need that view model. And that is why on the base view model, we have this initialize async method that gets overridden in the actual view models so that they only fetch their data when they're loaded into view. And now the last thing here is, how do they fetch data? How do they get data from the services? But we still need to look at the actual services, but how do we do service communication? Again, service communication is, well, it's basically very simple. It's REST. We use a REST service that we are going to communicate with. So we use from our Xamarin.Forms application an HTTP client or something else that is going to return us a JSON string, and we're going to pass that JSON string. Now, where are we doing that? Well, I'm actually doing that inside of the service classes. So, for example, if we go here into the service classes, I have a catalog service. And the catalog service, zoom out here, the catalog service implements, of course, the iCatalog service. That's an interface. It's registered using this interface in the dependency injection container. That in turn, for example, let's take a look at getCatalogAsync. The getCatalogAsync builds up the URI that we want to communicate with. Next, we are going to use something called the request provider to asynchronously get data from that URI. That is going to be a REST-based call that we're going to send a request to. We are using, in this case, the HTTP client, but it's not done in this particular class. It's done using this request provider. If we go and take a look at the request provider, the request provider is the low-level thing, the lowest layer, in fact, on the Xamarin.Forms application that will perform that will create the HTTP client for us, and then will launch an asynchronous request to that endpoint, which is then on the microservice. And we'll take a look at that in just a second. When the response is coming in, we are going to parse that, we're going to read it out, and we're going to parse that using JSON converts or using JSON.NET into objects that are then returned to the view model, and that basically gives us a working Xamarin.Forms application. Now in the backend, and I only have 3 minutes, so I'm going to go a little bit over time, so I'm going to scroll through here. Now in the backend, what is being used in the backend is actually a microservice approach. Now, why is that important? Because if you look at the applications that we have been building for so many years now, we have been building monolithic applications, right? The thing with this type of application is that some services, some parts of the application, in fact, are going to get a lot more load. For example, if our application becomes successful, a lot of people will be browsing the catalog, but not a lot of people will be buying stuff. So the basket service, the order service, they don't get a lot of traffic. And for that type of application, to make it possible in a cloud-based scenario where we scale only parts of the application, the type of client-server application that we've been building for so many years is not good, because that's a monolithic application. A monolithic application is one piece of code. You have your traditional tiered architecture in which you have components, but if you look at the components in your service layer, they are all tied together quite a lot. And that prohibits us from, like I said, scaling out different parts of the service. In a cloud era in which we are living now, this type of backend is not cutting it anymore. We need some different way to basically scale out if we get successful with our application. Now, this is what we used to do. If we have a client-server application, we have a backend, controllers, and MVC-based web API. When we want to scale out different blocks, different services, to say so, in my application, what you need to do when you want to scale it, well, you buy more service and you copy the entire application onto it. Like I said, that might work, but it's not ideal, because some parts of the application are going to be more under heavy load, under heavy strain than others. In that view, what we can work with for the backend is a microservice approach. Now, in a microservice approach, what we are going to do is we are going to cut up the application's backend in several functional parts. It's of course not as simple as simply saying we're going to cut it up, and why haven't we been doing this for so many years, but the idea is that we are going to decompose the application in several building blocks, the backend, I mean. For example, you have a basket service, a catalog service, and all kinds of different building blocks that in the end, composed together, give you the same functionality as your original application. But now, what you will end up with is an application backend that can scale out different building blocks independently. So instead of having to copy the entire application, you can say, well, my basket service, that's not very under heavy load. But my catalog service, a lot of people are browsing, so we need to be able to scale that independently. And that's where microservices and a microservice-based approach really comes into play. And because we're running out of time a little bit, I'm going to show you how the backend is basically set up. So we scroll down here, and like I said, it's not one backend. So typically we would have one backend that has a basket controller, a catalog controller, and so on and so on. That's not the case here. In this approach, the entire application is split up into several smaller applications, the actual microservices. For example, the basket API, that's something that we can scale out independently because that might not get a lot of users. We have in there just a basic controller, the basket controller, and like I said, the microservice is not really something to be afraid of. Right? You hear a lot of people talking microservices is complex. Well, it can get complex, of course, but this is just a plain controller. If you look at the basket controller, it is just a plain controller that is going to do CRUD-based operations in this case. It's going to get the stuff for the basket, it's going to allow to check out its basic functionality. But it's not really tied with other services because the other services are implemented in different projects, different separate standalone services. We have the catalog API, which also comes with a couple of controllers. There's a catalog controller, which again does CRUD-based operations. Now, if you look, for example, at this last service here, the ordering service, this one, as you can see, this one is done in a different way. It actually is using a domain-driven approach, using CQRS, by the way. I don't have time to show you all the code here, but this should also show you that some services are pretty simple to implement. And doing a microservice-based approach, we can do different approaches for different types of services. This one, for example, uses a domain-driven approach, while the other services, like the ordering service, don't have a lot of benefit from it. It's just plain CRUD. So using microservices, we can also evolve our services in a different way. If one needs to use a different technology stack even, you can do that because you have several building blocks inside of your application. And the last thing I also wanted to show you is that the application's backend is also going to be hosted, is going to be work in combination with Docker. Now, I'm running way out of over time here, so I'm going to only show you how it's basically done. If you look at the different services, there is a Docker file in there. So the different services are going to be hosted separately within a Docker container. There's a lot of other talks that go deep into Docker, so I'm going to show you only how it's basically set up. Every service is using a Docker file so that we can use to deploy the application separately. And then there's an orchestration project here down here at the bottom. So there's a Docker Compose project, as you can see here, that can be used. There's this particular file, so the Docker Compose file, allows us to orchestrate how the different backends, or the different services that make up the backend, can be combined to create a microservice approach, which we can then host inside of a Docker environment. So I'm sorry that I didn't have a lot of time to show you all the backend stuff in more detail. So the 45 minutes really killed my my total overview, as you can see here. I will show you all the slides. I will upload all the slides onto my blog. But I hope I've given you an overview of how an architecture for a real-life application can be set up using MVVM, because that was basically what I wanted to show you as the main meat of the application. Enterprise applications and Xamarin.Forms go hand in hand. A lot of line of business applications don't need more than Xamarin.Forms. You don't have to learn native Xamarin, but build them up using an MVVM-based architecture, because that can help you in the testability and the maintainability of the application. When you start building it, think of setting up your backend in a microservice way. It will give you the benefits of the cloud. It will give you the benefits of scalability. And of course, when you look at creating a new backend, definitely take into account that .NET Core, because this is all built with plain .NET Core, can really help you with the setup of this entire architecture. So I hope you enjoyed it. I want to thank you for being here. I hope you enjoyed it. I hope you enjoy the rest of the conference. And if there's any questions, come forward. I will handle them here. Thank you for being here.